Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's session we are going to discuss a numerical on the topic of motion under the influence of gravity. Okay, let's go to the numerical. A stone is dropped from the top of a tower which is 50-meter high. At the same instant or time, another stone is thrown upwards from the foot of the tower with a velocity of 25 meters per second. When and where the two stones cross each other. Okay. First of all, there is a tower with a height 50 meters. This is the top of the tower. This is the foot of the tower. The height is 50 meters. Okay. The linear distance between foot of the tower and the top of the tower, that is 50 meters. First, a stone is dropped from the top of the tower. That means from here, one stone is dropped. Okay. At the same instant, another stone that is thrown upwards. Okay. One stone dropped from top of the tower, another stone thrown upwards. Along this 50-meter distance, at any one of the point, that means say here, this is the crossing point. Both the stones cross each other. Okay, first stone dropped from the top of the tower, second stone thrown with some initial velocity 25 meters per second. Along the 50-meter distance, at any point, any one of the point, both the stones cross each other. That we are going to take, this is the crossing point. Okay. Okay. So this I'm going to take as the crossing point. Okay. So here only both the stones will cross. Okay. Because the first stone is moving downward, the second stone moving upward. So at this point, both the stones cross each other. Okay. The distance between the top of the tower to the crossing point, I'm going to take as S. Then we know that the linear distance between foot of the tower and top of the tower, that is 50 meters. The distance between the top of the tower to the crossing point, if you had taken that is S, then distance between foot of the tower to the crossing point will be the total distance 50 minus S. Okay, it will be 50 minus S. Okay. So here, this is motion under gravity. And here, the first stone is moving downwards. Second stone is moving upwards. So both the formulas we will use that I'm going to write at the sides for our purpose. Okay. So motion under gravity. Okay. Here, if the object's moving downwards, downwards means we know that along the direction of G. Generally, this we will take as height, but here we are going to take as S. Okay, S and 50 minus S. So I'm going to write the formula as V equal U plus GT, S equal UT plus of GT square, V square equal U square plus 2GS. Okay, this is when the motion is downwards. If the motion towards upwards, then the objects are against the gravity. Then we write the equations as V equal U minus GT, S equal UT minus of GT square. Then V square equal U square minus 2GS. Okay. So this is the topic belongs to the motion under gravity. When the object dropped downwards, free fall, plus G, these are all the equations. When the motion of the objects towards upwards, minus G, so these are all the equations. These equations I had written here for the reference. First, we start with the given data. Here, there are two motions. Like we have two objects. The stone one moved towards upwards, sorry, downwards. And it is dropped from the top of a tower. So the stone one, okay, the stone one, I'm going to mention with the suffix 1. It has the initial velocity u1 that equal to 0 because it is freely dropped from the top of a tower. Acceleration, we know that will be the plus g. And then here, the distance s1, I'm going to take as s. Okay. And here, the acceleration due to gravity is plus. And the equation also we had written here, so no issues. Stone 2, which one is thrown upwards from the foot of the tower. It has the initial velocity 25 meters per second. Its distance between the crossing point and the initial point, that means foot of the tower, that is 50 minus s meters distance. Okay. And this one is with the minus g. So here we know that it is going to cross at the same time. So the time taken in both the cases will be same. So here we are going to use the second equation in the downward motion and upward motion. And we are going to equate the terms to get the value of s. Then we will find the value of time. Like that we are going to do. So, solution. For the stone 1, okay, solution for the stone 1. Here you can see the stone 1, I'm going to write the formula. S equal the general equation. S equal, it is dropped downwards. So ut plus half gt square. That means this equation. Here now I'm going to substitute the values. Okay. here it is dropped from the top of a tower. So its initial velocity will be 0. When u equal to 0, the entire term will be eliminated. So we can write S1 equal 1 by 2, or that means of gt square. Here we know that S1 equal to S. So S equal to 1 by 2 g t square. Okay, t is also the unknown. This is the first equation. Then for the second stone, okay, that is for stone 2. Okay, the same equation I'm going to write S equal ut but minus of gt square. Okay, when the object is thrown upwards with an initial velocity 25 meters per second. So here we can see yes, that means S2, okay, that equal to u2t minus 1 by 2 g t square. Here S2 that equal to 50 minus S. That means the distance between foot of the tower to the crossing point. That is S2. Distance traveled by the stone 2 from the initial position, that is foot of the tower, to the final position, that means the crossing point. Okay. So S2 equal to 50 minus S. S2 equal to 50 minus S, that equal to U2 25t minus half gt square. This is the second equation. Now, instead of S, we have half gt square in the first equation. So substitute the first equation in 2. That is, substitute equation 1 in 2. Okay. Here, instead of S, substitute this value. That is S equal, 50 minus S. That is 1 by 2 g t square. Instead of S, we substitute the value of gt square. That equal to 25t minus 1 by 2 g t square. Okay. This side minus gt square, of gt square. This side also minus of gt square. Both we can eliminate. Okay. So we can eliminate the half gt square here, this side minus of gt square. This side also minus of gt square. So the remaining terms 25t, that equal to 50. So from this we can get t equal to 50 by 25, that is t equal to 2 seconds. Okay. So here, when the two stones cross each other, that means that is 2 seconds. Okay. Then we have to calculate where, that is yes. Here yes, we have of gt square. So S equal to 1 by 2 g t square from the first equation. So S equal to 1 by 2 into 9.81 into the 2 square. This will cancel each other. So 2 into 9.81, we will get S equal to 19.6 meter. It means that the distance between the top of the tower to the crossing point, that is 19.6 meter. In another way, we can say that two stones cross each other at a distance 19.6 from the top of the tower. If you want to mention this is from at the foot of the tower, that will be 50 minus 19.6. Like that, we have to say. Okay. So I just repeat that question once again. Just note it. Here, a stone is dropped from the top of a tower 50 meter high. A tower is there at a height of 50 meter. First stone is dropped from at the top of the tower. At the same instant, second stone thrown upwards. At any point along this 50-meter distance between the top of the tower and foot of the tower, both the stones, which one is dropped from top, which one is thrown from foot of the tower upwards, both cross each other. Here we have to calculate at what time and at what distance both the stones cross each other. Here, from the top of the tower to the crossing point, the distance we are going to take as S. So, the remaining distance, foot of the tower to the crossing point will be 50 minus S. Okay. So, stone 1 dropped freely from top of the tower, initial velocity 0, S1, that we are going to take as S. For stone 2, here it is thrown upwards with a velocity 25 meters per second, and its distance will be the remaining distance 50 minus S. This one is plus G. This is because this free fall under the influence of gravity, this minus G thrown with a velocity against the gravity. So stone 1, S equal ut plus of gt square. Here initial velocity 0. The first term will be eliminated. Instead of S, we are going to substitute S1, that equal to of gt square. This is the first equation. Stone 2, which one thrown upwards with a velocity 25 meters per second. So S equal ut minus of gt squared against the gravity. That's why here minus. So S2 equal u2t minus of gt square. Here S2, that is 50 minus S. We substitute that value. U2 25 into t minus of gt square. Here S and t, two unknowns are there. But in the first equation, we have S in terms of t. So now instead of S, we substitute the of gt square in the left hand side. So now this minus of gt squared at the left hand side, minus of gt squared at the right hand side, both will be eliminated. So it will be 25t equal to 50. So t equal 50 by 25. It means that t equal to 2 seconds. So this is the answer for when the two stones cross each other along the 50-meter distance between top and foot of the towers. Okay. Then to calculate where, that is yes, then you just substitute the value of t in the first or second, any one of the equation. Here first one is the simple one. So S equal of gt square or 1 by 2 multiplied with 9.81, t equal to 2. So 2 square. The square and this 2 will be simply cancelled each other. So S equal to 19.6 meter. Okay. So I hope you all understand this video. Okay. So subscribe for more videos, because in the further upcoming videos, we are going to discuss many numericals on the topic motion in straight line and also motion under the gravity. Okay. So to watch more videos, don't forget to subscribe. Okay. Thank you, guys.